Okay, we're continuing, or starting section 3.4, and this is basically graphing functions like polynomials. So we're graphing polynomials. First, let's start off with a simple polynomial, one that's in the form of something like this, where you have a as some constant, x raised to the nth power. So the most basic one in this case would be when a equals 1. So therefore all you would have is x to some power. If we were to look at your book in page 340, they've got several examples there, A through C of course. And as you can see on their graphs, figure 16, their graph is basically the same thing as each other. So we had, let me write this out so you can see what I'm talking about. X cubed, it's supposed to be a 3. X to the 5th, x to the 4th. So basically all of these, they're going to be, the way they ended up graphing them was just like I've always told you, to do a little XY table. And you pick some values for x and you plug it into the function, and then you'll eventually have your y, or your f of x. But in their graph of x to the 3rd power, so x cubed, it's looking like this. So this one here would be x to the 3rd, and that's this one. So x to the 5th, it's going to be real close to the same thing, but it's going to climb a lot faster because it's got a higher order than 3. So therefore, as you put in 2, 3, 4, 5, whatever value for your x value, you're going to get a much larger y value because it's raised to a higher power. This is x to the 5th, x to the 3rd, x to the 5th. So basically, just like they did in the book, you know, they chose some values, and you can choose whatever ones you want. These are some ones that they had chosen, and as you plug them into x to the 3rd, these are the outputs that you'll end up getting. And basically all they did was just plot each one of these points. You know, -2, -8, it's going to be somewhere down here. 0, 0 somewhere here. +2, 8 somewhere up here. And then the same thing with the x to the 5th. They just chose some values for x, plugged it in, and they got their y. And as they did that, they got a couple points on the graph, and then connect the dots. So, you know, basically your whole first example, or example 1, and basically example 2 for section 3.4 is things that you've already done. You're just dealing with a different type of function. But you're just going to choose some values for x and y, plug them into the function, and then plot those points and draw your line, which will eventually draw your graph. So as we've just previously seen, and it's even in your book, the graph of x cubed looks something like this, depending on your x values and your y values. But it'll be doing, you know, this type of shape on your xy axis. And if I were to, so this is x, f of x equals x cubed. So if I were to ask you to do f of x equals x cubed, let's say +1, as we did back in section, I think 2.7 or 2.8, where we were moving the graph up and down and left and right on the y and x axis, this one here, we would simply be moving up the y-axis 1 point. So it would be the same graph as the x cubed, but instead of going through 0, 0, it would be going through 0, 1. And it would look something like that. So this is something that basically you just have to remember. If you don't have parentheses around the whole function, it's going to move up or down on the y-axis. So if we had f of x -1, as you guys all probably already pictured it, instead of moving up, you're going to move down 1. So it'll be roughly the same exact graph, it's just going to be translated down on your y-axis 1 point. Let's get one more example up there like this. So one more example of translating. This time we'll move on the x-axis instead of the y-axis like before. But let's start off with a graph that we know because we've just done it in this lecture. So this graph will look kind of like the x cubed, but it's going to climb and descend up and down the y-axis much faster than what x cubed would because it's got a higher power. So as you plug in some x value, you're going to get a much larger y value for that same x input. But for an example, see what we'd be doing here. If we had the parentheses that were enclosing x to the fifth, let's say, not 1, let's do 2. Oh, whoops. Sorry, this fifth shouldn't be there. It should be out here. So if you see it like this, as opposed to the last time I think we had it do something like this, you see the difference. You see now we have parentheses, and everything inside the parentheses is being raised to the fifth power. And the last page that I had up here, it was like x cubed minus 1. So the 1 wasn't being raised to the third power, and there weren't parentheses. So because it was like that, we moved up and down on the y-axis. But now when it's like this, when it's everything's contained and raised to the same power, you can move left or right on the x-axis. And it's kind of counterintuitive. So because we have a minus 2 inside the parentheses, you would want to automatically say, well, let's go ahead and move to the left to the negative side of the x-axis, which is over here. But you're not going to do that. You're actually going to, like I said, counterintuitive. We're going to move to the right 2 places. So it's going to be the same graph as over here, but you're basically just moving it 2 places to the right. So in this case, you're translating or sliding or moving your origin to this point here. Okay, and you can validate this by, you can do this XY table and choose some points. Because 2 is our origin, just to check this, you plug 2 in for x, so 2 minus 2 is 0, 0 raised to the fifth power is 0. So obviously this point here is accurate, and I can guarantee you all of these points that are along this graph are also accurate. So if you chose 1, you would get what? You would get negative 1. So at 1, you're going to be sitting right here at negative 1. At 3, you're going to be sitting right here at positive 1. So these are all ways you can check it, but as long as you know your base graph, if you add or subtract something and it's all contained in parentheses, then you're going to move right or left on your graph, but it'll be the same graph. It's just going to be moved left or right on your x-axis. And if it's written like the one up here where there's no parentheses, then it's going to move up or down along your y-axis.